the topic that is differential equation. In that we are defining the first order, first degree differential equation. So there are two standard form of first order, first degree differential equation. First one is dy by dx equals to f of xy, or we can write the first order first degree into this form, m of xy into dx plus n of xy into dy equals to 0. Okay, why it is called as the first order first degree? If you see, we are having a first order differential coefficient. Okay, highest order differential coefficient is first order, therefore it is called as the first order, and exponent of this, it is what? 1, therefore degree is also, it is 1 here. So this is the first order first degree differential equation. Now if I look at the second form, so the second form can be written into this way also, it is m dx plus n dy equals to 0, where this m and n will be the functions of x and y, and we can obtain one form from the another form very easily. जैसे अगर मैंने ये form consider किया, okay, I take this quantity to the right hand side, ये मैंने यहाँ पे right पे लिया, then I write down this as a dy by dx. I can write this as a dy by dx. It is permitted in the differential calculus. I take this n here, so this is the function of xy, this is the function of xy. It is completely a function of xy and can be represented by this f of xy. So we are having a dy by dx equals to f of xy. The second form converted into the first form. Similarly, we can convert the first form into the second form. And the first order first degree differential equation हम सभी solve नहीं कर सकते हैं. Solve किसे कर सकते हैं? जो ये following form में आते हैं. अब following form कौन से हैं? अगर हम equation को रख सकते हैं into this form, that is linear differential equation के form में, या otherwise we can reduce, that is reduce to the linear differential equation, or we can solve the equation of the type कैसे? exact differential equation जो आएगा, या otherwise reducible to exact differential equation. Okay, or we can solve the homogeneous differential equation, and or maybe a reducible to homogeneous differential equation. These are having some standard definitions, so we are not seeing here, just seeing the name. Or if the equation is written into this form, that is a variable separable form, can be solved. Okay, जो इस form में आते हैं उसी को हम solve कर सकते हैं, otherwise बाकी equation solvable नहीं है. So we'll start here first of all with the first one, that is a linear differential equation. We define what is a linear differential equation. So definitions here: an equation of the type that is dy by dx plus py equals to q, where y is the dependent variable, x is independent variable. Okay, and this p and q are the functions of independent variable, that is x, and or that this p or q may be a constant term. So this equation, ऐसे equation को हम कहते हैं linear differential equation. So definition says that a dependent variable and its derivative, that is dy by dx, that must occur in the first degree. दोनों फर्स्ट डिग्री में आना चाहिए, एंड दे आर नॉट मल्टीप्लाइड टुगेदर, मतलब y इंटू डी वाई बाई डी का टर्म नहीं होना चाहिए इक्वेशन में, देन दैट इक्वेशन इज सेड टू बी अ लीनियर डिफरेंशियल इक्वेशन. अगेन आई रिपीट द डेफिनेशन: द डिपेंडेंट वेरिएबल एंड इट्स डेरिवेटिव मस्ट कम अंडर द फर्स्ट डिग्री एंड दे आर नॉट मल्टीप्लाइड टुगेदर, then the equation is said to be a linear differential equation where this p and q are the functions of independent variable or a constant term. Now how we write down the solution for this differential equation? Solution, I tell you, solution is nothing but the relation between the dependent and independent variable which satisfy this equation. Okay, that is called as the solution. So solution is written for this LDE as dependent variable. You have to write first of all. Okay, here what is the dependent variable? It is y. Into it is integrating factor. So integrating factor we take as e to the power integration of p dx. Why we are taking this integrating factor? I'll convey you later on. And then equals to it is integration of the q. Q is what? It is a RHS part of the equation. It is q into integrating factor. Again that I we have written it is e to the power integration of p dx into dx plus c. And this c is our integrating constant that we are writing. So this is the solution for this LDE. That is y e to the power integration of p dx equals to integration q e to the power integration of p dx dx plus c. One more thing, the integration we are doing with respect to the x, and what is this x? X is nothing but the independent variable. तो आपको हमेशा याद रखना है जो हम इंटीग्रेशन करते हैं वो हमेशा इंडिपेंडेंट वेरिएबल से करते हैं. ओके, सो दिस इज द डिफरेंशियल इक्वेशन ऑफ द फॉर्म dy by dx. अगर कभी कभी इस फॉर्म में हम इक्वेशन को कन्वर्ट नहीं कर पाते हैं, वी कैन कन्वर्ट द इक्वेशन इनटू दिस फॉर्म इजीली, दैट इज dx by dy plus px equals to it is what? q, where x is the dependent variable. So here dependent variable and its derivative, that is dx by dy, are occurring in the first degree and they are not multiplied together, and this p and q will be a functions of y or maybe a constant, then this equation is said to be a linear differential equation in dx by dy. That is a linear differential equation in dy by dx. Okay, now solution for this will be then given by, it is dependent variable, it is what, x. The integrating factor will be here now e to the power integration of p dy. वहाँ पे क्या था, e to the power integration of p dx, यहाँ पे रहेगा फिर e to the power integration of p dy, because p is a function of y, तो हम उसको y से इंटीग्रेट करेंगे, therefore it is e to the power integration of p dy, that is if equals to integration, then this is q, again if, that is integrating factor, into dy plus c. Again we are doing the integration with respect to the y. So this is the solution for dx by dy type of the LDE, linear differential equation. Now what is this integrating factor actually, how it is obtained, I will tell you. That is, we are having this equation dy by dx plus py equals to q. Now I multiply this equation by the factor e to the power integration of p dx. If I multiply both the side by that factor, so I will get here e to the power integration of p dx dy by dx plus py e to the power integration of p dx, again I multiplied by the e to the power integration of p dx here. Now after that, if you observe the LHS part, I can write down the LHS part as the differential of what, y into e to the power integration of p dx, and the RHS is as it is. Okay, now you have to apply here the product rule. You know the product rule, it is the first function integration of first function derivative of second plus second derivative of first, that is called as the product rule. So if you observe here, so I have the taken the first function as suppose y, so this is y as the first function. Now I take a derivative of this second function, that is of exponential, that will be same. Then the derivative of the power, okay, I am doing the differentiation with respect to the x, so then this integration will get cancelled, I have only it is what, p. So the first function derivative of second, then plus we are having the second function we write down as it is, then the derivative of first with respect to the x, and that will be dy by dx. So this quantity can be reduced into this form, that is the differential of y into e to the power integration of p dx. Now we have to form a solution. Now why it is called as the integrating factor? Now because of this quantity, that is e to the power integration of p dx, this quantity we have reduced into this form, now it is integrable. अब ये integrable हो गया है, therefore it is called as the integrating factor. Okay, now we can do the integration very easily. If I do the integration, this d will get cancelled, and we are having this quantity that is written here, y to the power integration of p dx, and then we are doing the integration of this RHS part with respect to the x, and then adding the, it is what, integrating constant here, that is plus c. So this way we solve, that is, this is the basic concept of a linear differential equation. You just remember the two things, equation will be, you have to reduce into this form where the coefficient of dy by dx is what it is, 1, वो करना पड़ेगा आपको, and you just have to check whether the dependent variable and its differential coefficient are in the first degree and they are not multiplied together, and this p and q are the functions of what is it, independent variable x. तो उसको हम linear बोलेंगे, और उसका solution कैसे लिखेंगे, फिर it is y e to the power integration of p dx equals to integration of q e to the power integration of p dx dx plus c. You just remember this formula, this is important, okay, because while solving the example we require this formula, so you just remember this one. Okay, thank you. So this is the just complete information about the first order first degree differential equation as well as the linear differential equation. Okay, thank you.